So in this topic, we will be talking about a particular type of refraction that may occur, and that is total internal reflection. Now, this occurs when light travels from travels from denser to rarer medium. So first, let us get the setup of this whole situation. Say suppose this is your two medium. This is your denser medium, and this is your rarer medium. Rarer medium. So now we know that when light travels from denser to rarer medium, the angle of refraction is greater than the angle of incidence. So say suppose a light is coming over here. Let me draw this with a different color. Say take this black. Okay. So while it's coming over here, this is my angle of incidence. So if this is angle theta, we know that it will deviate. It will deviate. If this is angle of incidence, this is angle of refraction. So it deviates. From denser to rarer, it deviates. So if I increase this angle, this deviation will be more. Then there will come a point when, say suppose for this particular angle, say suppose I have drawn another angle, say let this angle be angle of incidence I. Now we will see that it deviates so much that this ray is refracted parallel to the surface. This is refracted parallel to the surface. Now beyond this point, if you try to look beyond this point, if you increase the angle a bit more, so beyond this point, this particular ray would not be going outside this medium, but instead it will be reflected back from the medium. So this will act as a mirror, this will act as a plane mirror, and it will send this incident ray back to the same medium. So it keeps on getting deviated, then there comes a position or there comes a time when this ray travels parallel to the surface. So after some time, we see that this ray is totally reflected back. So there occurs a phenomena of total internal reflections. You can see that this has been reflected internally, and this is what is called as total internal reflection. So if you want to find the mathematical criteria of total internal reflection, all you have to do is, if you want to find at what angle should you let the ray travel so that you have a total internal reflection. Now for let's take the boundary condition. Boundary condition. So what is boundary condition? When this line moves parallel to the surface. So the boundary condition was sin I. We don't know what should be the angle of incidence, but we know the angle of refraction is what? This is 90 degree. It makes 90 degree with the surface. So this is sin 90 degree, and this is equal to mu 2 of 1. That is refractive index of medium to with respect to 1. And sometimes it is also written as n2 of 1. Okay. So now what you can see is this, which is equal to, now this is equal to or implies sin I. Now what is sin 90 degrees? Sin 90 degrees is nothing but your 1. So this is implies mu 2 of 1. So this is a criteria for total internal reflection. Now what is I? I is the angle. I is sine inverse of n2 of 1. Now for your convenience, in your NCERT book, they have taken n2 of 1. That is refractive index of medium 2 with respect to medium 1. So for now, I'm taking this as n. Sometimes in your book you may get this as mu. So do not get confused because both represent the exact same thing. So this is what you can understand as a condition of total internal reflection.